know why the thing talks at me. I don't even know if you heard that, but my computer just talked at me. Either way, if you're watching this video, it means you're about to take a quiz for me. Yes. Yeah. So the big thing with my quizzes, number one, there's a lot of different strategies that you can use for a quiz. I'm always a big fan of get the article on Notability yet, and if you don't know how to use Notability yet, it's an app on your iPad, and you can have Canvas up on one side and the article right next to it. And once you get that article in Notability, and literally just download it, click the share to Notability, and it's going to be there. Once you have the article up, go ahead and scroll through all of the questions in the quiz. See what you need to find out. Let's see, how many questions total is this quiz going to be? I do believe it is. I said it was worth 10 points, but there was a couple of questions that I wanted to keep in there from the article specifically, plus the 5 themes question. So we're looking at a total of 14 points with 5 questions over the 5 themes. 1, 2, 3, 4 questions from the article, and actually 1 question is, hey, read this or look at this and answer a question based on this. Yeah, so use your notes. They're going to be helpful when it comes to describing location, place, region, human environment interaction, and movement. So let's get to it. I'm going to read this article to you, and you're going to take the quiz. I'll probably play this video in class. Sorry. Believe me, it's more awkward for me because everybody hates hearing themselves talk, and I'm going to hear myself talk for 6 periods. So you're probably going to turn around now and go, he looks weird. Yeah. I look weird now. I'm like, I look different from what I do right now in that seat back there. So I'm wearing a suit, not a suit, but a tie today. All right, so let's get to it. The title of the article is called Chernobyl's Legacy. The reason why I chose this article is that this event in Chernobyl had a huge impact on how human beings get power. We need power. Your iPad that you're using right now needs power. The air conditioning that hopefully is working right now needs power. The scoreboard that I'm looking at right now needs power. We need energy, okay? So let's learn about something that might potentially go wrong with energy. So let's go. Chernobyl's legacy. Chernobyl. The name refers to both the town and a nearby defunct power plant in what's now Ukraine. But to many people, the name has become synonymous with nuclear disaster and what can go horribly wrong in the world's quest to electrify cities with nuclear power. The explosion of one of the plant's reactors exposed hundreds of thousands of people to radiation. It forced some 350,000 people in the surrounding areas to leave their homes, according to the International Atomic Energy Agency. Access is still restricted to what's known as an exclusion zone, which encompasses the land within 30 kilometers of the plant, or 18.6 miles. But more than 100 people now live in or on the edge of the zone. Much of the soil remains contaminated with radioactive materials. The scientists monitoring the zone say that breathing the air is safe. Details about the causes of the explosion have been well reported, but the world is still contending with its lingering effects and fears of another Chernobyl-like event. More than 30 years later, are the concerns still warranted? And we see a map of where Chernobyl is at, what country it's in, what other countries it's close to, and some pictures from Chernobyl. These are super creepy. Like when you're done with this quiz, if you want to Google like Chernobyl pictures, Ooh, it's weird. Anyways, back to the article. What caused the explosion? In the spring of 1986, operators at the Chernobyl power plant set out to conduct a safety check to see if the plant would work safely if the main power source were interrupted. As part of the safety test, one of the four reactors was reduced to a low power state. A series of operator errors coupled with the reactor's poor design led to a power surge at 1:24 a.m. on April 26th. The rush of energy was enormous. It caused thermal power to reach a level of 12 billion watts. The pressure inside the reactor shot up and the temperature reached a staggering 4,650 degrees Celsius or 8,402 degrees Fahrenheit, about the same temperature as parts of the sun's atmosphere. That's hot. These conditions inevitably caused the reactor to melt down, and an explosion blew the steel and concrete structure to bits. Metal, graphite, and lethal radiation was blown sky high. Winds blew a radioactive cloud across northern Europe. How did the reactor work? The reactor was a Soviet-produced RBMK, or Reactor Bolshoi Moshchunsky Kanali, which translated from Russian means high-power channel-type reactor. In the core of the reactor was the fuel, 190 tons of enriched uranium dioxide, UO2. The uranium is said to be enriched because it contains a higher percentage of the isotope U-235, the isotope used for nuclear power, than is found in naturally occurring uranium. Naturally occurring uranium has approximately 0.7% of U-235 and more than 99% of the heavier isotope U-238. Enriched uranium is 3 to 5% U-235. When the nucleus of a U-235 atom is bombarded by a neutron, a nuclear reaction takes place. The neutron splits open the nucleus, a process known as fission, and releases new daughter nuclei, more neutrons, and energy. The reaction can play out in many ways, generating different products depending on the conditions. The following reaction is one example of what can happen to U-235. The reaction of a single atom of uranium does not release very much energy. The reaction above typically produces about 2.7 times 10 to the 11th power joules, but repeated on the scale of the mole, that is 6.02 times 10 to the 23rd power times, or 235 grams of U-235, the energy released becomes significant, about 1.6 times 10 to the 13th power joules. That's enough to power 400 average US homes for an entire year, all from the reaction of about half a pound of U-235. About the isotopes. Isotopes are atoms of the same element, meaning that the atoms contain the same number of protons and electrons with different numbers of neutrons. For example, U-235-92 and U-238-92 are isotopes of uranium. More pictures of Chernobyl. Controlling the reaction. Nuclear power is based on two properties of nuclear fission. One, it produces a large amount of energy when scaled up, and two, the neutrons that are produced can react with an additional U-235 nuclei, breaking them apart and producing more neutrons. The result is a self-sustaining chain reaction. The chain reaction produces a lot of energy very quickly. Without moderation, the process becomes dangerous. Careful monitoring and management are required. One way to control the reaction is to lower control rods into a reactor's core. Control rods slow down nuclear reactions by absorbing neutrons, which prevents them from reacting with the uranium and generating more energy. Chernobyl's RBMK reactor had 211 control rods. The accident investigation showed that at the time of the explosion, only 8 control rods had been in the 7-meter tall core when at least 15 should have been in place. This critical error, along with subsequent missteps, ultimately led to the explosion. The human toll. As a result of the initial explosion, 2 people were immediately killed. In the following 2 weeks, more than 24 people died from acute radiation sickness, or ARS, which occurs when exposure to radiation goes well beyond background levels. The ionizing radiation produced in nuclear reactions damages human cells. This leads to a host of symptoms, including vomiting, diarrhea, headaches, and fever. Over time, cancers such as leukemia can also result. Long-term health effects can also result from the radioisotopes that the explosion spewed into the atmosphere and settled into the soil and water. As mentioned earlier, the nuclear fission of U-235 can yield many different lighter products, which can undergo radioactive decay to create a mix of radioisotopes, such as iodine-131, cesium-137, and strontium-90. These radioisotopes can cause a variety of health issues. For example, iodine-131 tends to concentrate in the thyroid gland and can cause cancer. Strontium-90 can mimic fellow group 2 member calcium, accumulate in bones, and lead to bone cancer. Iodine-131's effect is relatively short-lived with a half-life of only 8 days. In contrast, cesium-137 with a half-life of 30 years and strontium-90 with a half-life of 29 years remain threats for longer periods of time. The number of premature deaths that have resulted from Chernobyl, however, is difficult to determine. An estimated 600,000, quote, liquidators, end quote, were brought in to clean up the mess that resulted from the accident. Some of them died of cancer or became terminally ill. In addition, an increase in thyroid cancer rates in the region has been reported. Nuclear power today. After the Chernobyl disaster, RBMKs were redesigned and no major incidents involving this type of reactor have been reported for 2 decades. The most recent nuclear meltdown occurred in 2011 in Japan when a tsunami flooded the Fukushima Daiichi power plant. No deaths or cases of ARS were reported. Nuclear power continues to be an important contributor to low carbon energy, although concerns about safety, long-term waste disposal, and high building costs have dampened the industry's growth. Moving forward, the world could become less reliant on it as a renewable energy such as solar and wind continue to ramp up. Even then, the legacy of Chernobyl will endure. Information on reactions and radiation. A little graph on understanding half-life. Yeah, interesting stuff. That'll pretty much wrap up that article. Hopefully it was interesting to you. And with these Friday quizzes going to be here all year, especially in geography, what I want to do is literally expose you to new things that you've never heard before. Like, I hope some of you have never heard of the Chernobyl disaster before. And like I've been saying for the past couple of days, you can talk about the Chernobyl disaster, tattoos, I'm looking at you, 6 period, the news, anything through the 5 themes of geography. And that's what a majority of this quiz is all about. So that'll do. Read the article as much as you can. Remember, I am grading these things on Sunday morning. So get this done. It is due today in class. Make sure you hit submit when you are finished. And if you don't like your grade on Sunday morning, get used to coming in on Monday morning and let's chat. I love talking about grades, but I love talking about grades in August instead of 3 days before the term ends. Know what I'm saying? So that being said, I am signing off. Good luck. Godspeed. Complete sentences and answer the question. Don't write about whatever you want to write about. Answer my question. See ya.